Hi everyone. My name is Dan Young. I'm gonna be the instructor of this algebra course, Algebra 2. We're in Algebra 2, okay? Of this course, let's see. Has anyone taken any class with me before? Let's see the chat. No, okay, cool. That's good. Okay, so we're gonna do a quick introduction and I'll go over the course with everyone, and then we're gonna do like a trial for today, which is chapter 1 about function of algebra 2. Okay, sounds good. Most of the time I have my camera off, and I'll share the screen with everyone, and just so we can keep up with the lesson and everything. Let's see. Okay, hello everyone. Okay, so far I have 13 students. Okay, all right, cool. So let's see. Can you all like use the group chat? I mean, use the chat feature, or just say whatever, like tell me what grade are you in? Hi. Yeah, just kind of like tell me what grade you in, and you in 3rd grade. Oh wow, 3rd grade taking algebra 2, going into 8th. Okay, 9th, 4th grade. I have 1st grader here. Oh wow. Okay, wow. 6th grade. Okay, wow. Oh, hi. Hi, Miss Shippen. You parent. Okay.
Hi.
Hi. Oh, Mister. Sorry.
Yeah, I just wanted to see how you guys run the course and
Oh yeah. Yeah.
before I make decisions.
Yeah. Definitely. Yeah. Definitely. You're welcome. Yeah. Welcome. Welcome.
Thank
Yeah. So again, Miss Null told me this is like an introduction class. So I'll go over the course, all the topics that we'll cover during the semester. And yeah, so today we're gonna start chapter 1 for function. Oh wow, so I have 3rd graders, 9th grader, 1st, 4th. Oh wow. Okay, very impressive. Okay. All right. How about everyone else? What grade are you in? 4th? Okay. Okay, so just a quick question. Can anyone here tell me if you have taken a pre-algebra class before? I just want to, like, although you're in different grade, okay, cool. I just want to make sure everyone's on the same page. Okay, cool. All right, so looks like most of you already took a pre-algebra course, which is good, which is highly recommended. You took algebra 1, okay. I know, I was just making sure. Wow. Already sassy, huh? Okay, cool. Okay, yeah, so that's great. I just want to make sure everyone's on the same page, because if not, that would be hard. That would be challenging. So, okay, so I'm gonna go ahead and get started, okay? So, all right, so like I said, today we're gonna, so before we talk about today's unit, here. Oh yeah, so Guys, just want to let you know, I'm pretty familiar with using Zoom and all that. So I don't think there would be any questions. I mean, there would be any like concern or like difficulties. But if that happens in the future, um, I'll try my best. But so I usually have my screen shared with y'all during the section, so it's probably hard for me to keep up with the like the chat. So if you have any question, I do have my chat pulled out here, but sometimes I get caught up with the lesson. So feel free to interrupt me, either raise your hand or just unmute yourself, and yeah, just ask question, okay? And also this class, I don't want it. I don't want it to be just me talking. I kind of like want the interaction between everyone. So as I go over the lesson, I'll like introduce the lesson to you first. I'll give you some examples, and then it will be more like we working on the problems together. Okay, I'm gonna have you try. Feel free to make mistakes or like try your best, and then we'll get back together and then we'll do the problem together. Okay, sounds good? All right, yeah, to me that's like the best way to learn, because I want you to try first, and then you learn from making mistake and things like that. Okay, so for algebra 2 course, we'll go here. I can show you the schedule quick. So so we'll go over functions. We'll do system of equations. We'll do some quadratics and complex. So quadratic functions mean function with degree of 2. Okay, so it's no longer linear function. We're talking about quadratic functions, so like second degree functions. So we move on to polynomial. We're gonna do exponential functions. We do sequences and series, data analysis, and probability. So yeah, things like that. And then, so this is just like the basic. However, when we get to the official class, I'll send you guys, I usually write my own lesson plan. And so after each class, I'll email everyone a set of homework problems, but don't be scared yet. It won't be a lot. It's just like a few problems to make sure that everyone understands the concept, okay? And then we'll go from there, okay? So any questions so far? No? No? Okay, cool. All right. So with that being said, I'm gonna go ahead and start the unit for today. Okay. Okay. So today's unit is pretty straightforward. It's basic functions. Can anyone tell me without looking at the screen, like tell me what you know about function? Can like definition of function or anything related to function? Anyone? You can either feel free to type or talk directly to me. It's okay. Anyone? Yes, Zach, go ahead. Oh yeah, equations. Oh yeah, so here's the thing. So yeah, you write equation with one input and one output. Yeah, yeah, good job. Yeah, Sophie. Mm-hmm. Adrian. Yep, so it's good. Mm-hmm. That's good, everyone. So basically, oh wow, okay. You even know inverse function and all that. That's cool. So yeah, so typically a function and equation can like similar, but function usually we write function in term of, let me do like a handwriting. How can I draw on this? Okay, yeah, so here. So like a function, wait, oh, it doesn't let me, okay, it's okay. Where's zoom feature? I taught this course over summer and now I forgot. Oh, I forgot that I have to record this as well. Oh, okay. Okay, it's automatically recorded. Okay, cool. Each x, okay, each x value only has one. There's one, but anyway. Oh yeah, Kaylee, that's perfect. Yeah. The chef's not first grader. No, definitely not a first grader. Yes, very good. Yeah, so that's good. So yeah, a function is a relation in which each element, they use the term element, right? But technically, I call it an input, okay? So of the domain, so in this case, again, they use another terminology. So domain is just like a set of all input values, right? So for example, like we call the Collins family, right? So when we talk about the Collins family, that's like kind of like the domain. So all members of the Collins family are the X values, okay? So that's what the domain's for. So the domain is a set of, no, I was just using it as an example. So yeah. So yes, so that's what the domain is, okay? So each element of that domain, so each input is paired with exactly one element of the range. So another term here is range. So range is just a set of all output, okay? So we have input and output, okay? So the one important thing about function is an expression only a function if we have, for each input, we have one and only one output, okay? For each input, we have one and only one output, okay? So our function discrete is a series of unconnected points. So you see, like, if you graph, it says graph an expression and the points scatter everywhere, we call it discrete, okay? And then function is continuous. A graph you can draw without lifting your pencil. So this is like a very basic definition, okay? So how do you know if like a given expression is a function? So there are multiple ways. So first way is that you can do this. So you check the input and then you check the output. The second way is that you can graph it. And so when you graph it, for example, this graph right here, okay? So when you graph it, you use the vertical line test. If you draw a line parallel to the y-axis, so this is y-axis, okay? This is x-axis. For any chosen value of x, it must intersect the graph only once to be a function, right? So if you are given a graph, you can use a vertical line test to see if it's a function or not. Again, relations functions can be represented by equations. Again, we have input, which is x values. Again, I can use any letter, okay? It doesn't have to be x all the time. I can use I can use A, B, you know, whatever I want. So I call those input. So my input values are independent, okay? Why are they independent? They are independent because they are the values that I can pick like randomly, right? So if I give you a function or an expression says give me one input, you don't have to think at all, just pick a number, right? So that's why they are independent. And so how about y value here, which is the output, right? So the output are always dependent. Why? Because these output depend on your input, right? Can I be imaginary? Yes, I can be imaginary. That's why before imaginary, I don't use letter I. I'm just saying like in general, the input or the output, I can use any letter other than X and Y. Yeah, so that's just my explanation for, yeah, so we'll get to that later. But I mean, in general, I can use any letter for the input and the output, okay? All right, so when I ask you to evaluate a function, all you have to do is just substitute, and then you simplify, you do all the math, and then you give me the output. Easy, okay? All right, so let's do some examples together. So here, give the domain and range of each relation. State whether it's a function or not, right? So for the first example here, the domain and range is very limited. So can any of you quickly tell me what the domain and range is? So again, domain is a set of all inputs and range is the set of all output. Very good. Yeah. So I see some answers using bracket. So can anyone tell me why bracket, not parentheses? Oh, wow. You guys very good. I'm excited to teach this course. Why bracket, but not parentheses? Yeah, very good. That's good explanation, Ian. Yep, good job. Okay, so yes, wait, correct me if I pronounce your name wrong. How do I say it? Risha? Is it your first name or that's like first and last name together? Richard. Yeah, this is the tryouts. Yeah, so it's a tryout. So yeah. So like, even though it's a tryout, I want to make it like an actual class. I mean, yeah, it's a tryout, but like the actual class will have like we'll use my own lesson plan, not something similar to this, but it's yeah, okay, yeah, thank you. But yeah, so again, this is a tryout, but again, I want to go over the lesson just so you have the idea of how the class goes, you know, like that. Yeah. So again, during the section, I really like, you know, because we're doing online, that means really hard to like know you personally. So that's why I like interaction. I like asking questions. I want to make sure everyone involved, and you know, I want to make sure everyone with me. So there would be a lot of questions, would be a lot of like comments and things like that. So yeah, that's why I want to make it look just like an actual class, right? Yeah. Okay, so let's get the rest and not function. Oh yeah, okay, so here, let's take a look. Let's take a look here. So yeah, you guys are right, the domain between 1 and 5, right? Why? Because right here, you see 1 is included. That's why this dot right here is closed, right? We have closed and open, okay? So this is closed. That means Y is actually in the domain. And then same thing for 5. 5 is in the domain. That's why the circle is closed. That's when we take a look at the x-axis. So that's when we talk about the domain. Yeah, thank you. Good job, Ian. And then for range is 3 to 4 because it's ranging from here to here, right? So is this a function? Of course it is. Okay, how about the next example? Yeah, okay, you guys are good. So all the domain are here, listed here, right? Which is obvious. And all the range is over here. So is this a function? So let's check, right? So I said every single output, I should only have one and only output. So for 6, when I plug in 6, I have -4. So it's good, right? So when I plug in 6, I only have -4 as the output. So that's good right there, check mark there. So for 7, I only have -3. So that's good. For For 8, I have -3. For 9, I have -6. So this is a function. Yes. Okay. All right. So over here. So this is easy. So so domain is easy, right? I just have to list all my numbers here under X. And then Y, again, the range, list all number there. However, is this a function or not? So let's check, right? So here I see that I see that -1 repeated. So for one input, -1, I have 3 different outputs, right? So does that say something? This is not a function, which everyone's right. Yeah, that's good. Okay, so now let's finish up this and then we can, here, let me change this to continuous. Yeah, make it bigger. Okay, so now, next example. I have, the graph shows the length of the Tour de France in kilometer each year from 1998 through 2006. Is the relation discrete or continuous? So which one, guys? You see, yeah, very good. The points can like scatter everywhere. Yeah, very good, everyone. Thank you. See, I like that. Yeah, just to make sure that I'm not talking to a screen, you know, like I like this. Okay, so good job. And oh gosh, of course I show you the second question. Sorry. Okay, yeah, so it is discrete, which is everyone's right. Does the graph represent a function and how do you know? So, well, let's look at the graph instead of the answer. So we can draw a vertical line test here, right? And then we see that for each input, we only have one number for the output, right? So yes, it is a function, right? Any questions so far? Any questions so far? Anyone? No? All right, moving on. Okay, so third problem. So you'll run into problems like this under unit 1 about function. I'll give you a function, for example, this, right? And then I ask you, oh, so what is the output? Okay, so that's just so you know. So here in this case, my function named f of x. So what does that mean? It means my x here is the input and f of x gonna give me the output, okay? So if I plug in, so if I see f of 6, what does that mean? I replace x with 6, right? And then I calculate it, okay? So when I'm done, that gives me the output, okay? So same thing for b. So why don't you guys go ahead and try finding the value for f of 6 and f of -2, please. Ooh, okay, you already started? Okay, cool. Thank you. Wow, you guys are great. I like this. For some topics, I might do something like more enjoyable, just so you know, like make it go a little faster for everyone. So we can do something like we can. I tried. Let's see. I forgot what it was, but in the summer when I taught the same course, I did something like Jeopardy. Something like that, I forgot, but it seems like everyone enjoyed it. Yeah, I got the answer, which is right. So when I plug in 6 here, right, 6 squared, which is 36, and then I multiply by 2, and then I minus 8. Make sure when you do this, you do PEMDAS, right, order of operation, which is great. Everyone got the answer, 64 and 0. Good job. Okay, so let's move on to example number 4. So consider the function rule, multiply the input by 2 and then subtract 1 to get the output. A, fill in the table below for inputs and outputs. Oh gosh, okay, I already showed you the answer again. Well, oh yeah, I forgot to tell you. So one thing that I have not found a solution to yet is graphing. So when I taught the course in the summer, we had that problem. Whenever I have like graphing question, it's just hard to like, it's just hard for me to see you guys answer. So if anyone knows a way to help me fix the problem, please feel free to. I would much appreciate it. Okay, thank you. Yeah, so for C, graph the function. Anyone can take over. Feel free to. You guys can draw on this if you want to. But yeah, she got rid of it. Wait, what? Oh, Miss Null? Oh, really? Oh, I did? I'm not sure how to fix that. Oh, really? Oh, maybe Miss Null did it on, yeah, some of you, right? Maybe she did it for a good reason. Yeah, no wonder. Because I can't, like, I can't even draw on it something. Just annotate. Yeah, but like, so yeah, I mean, we tried that, but like, that only like give one person to do it. You see what I mean? Like, I want to see, yeah, I want to see everyone's answer. So like, if I let you annotate my note, like, there's only one person can do it. Don't make it public because people might draw all over. Okay. Well, I'll try as we go. There should be an option to let us. Yeah. There is. Yeah, there's an option, but I'm just like, you see what I mean? So like, if I have you draw the answer, there's only one person can do it, and the entire class can see that. Like, I want to see everyone's work at once. You see what I mean? Yeah. So like, I'm still trying to find like the best option for that. Because last like when I taught this course over summer, it was really hard. Like, yeah. But anyway, it's after you do it, then there's an option to enable it. Oh, okay. Okay, I'll work on it and see how it goes. Yeah. So that's my point. But okay, yeah. So yeah, thank you everyone. We'll just skip the graph for now, and then write a. So yeah, let's move on to part B here. Write an equation that gives this rule in symbolic form. So why don't you guys try writing an equation that represents a function for me, please? Yeah, that looked good. Yeah, so that should be, yeah, thank you. Oh, that's new. Thank you. Delbert, did I say your name right?
Yeah.
Thank you. Okay, so yeah, so you got that right. So did everyone else. So yeah, this is easy from here, right? You can see the pattern. Like, these are your inputs, and then 2, that's your constant number, and then you just subtract 1. So that's it. All right, so in the function rule for what input would be needed to produce. Oh yeah, okay. So I'll make the screen a little smaller just so you can see. Okay, so in function rule from problem 4, which is up here, what input would be needed to produce an output of 17? Why is it harder to find an input when you have an output than finding an output when you have an input? Yeah, that's good. It is 9. It is 9. So well, so I get the question asking, like says you are given the output and why is it harder, right? Because anyone has any answer for that? Yeah. Uh-huh. That's good. That's a good answer there. Yep. So we can go back to this problem, for example, this one, for example. See, so I'm just talking in general here. I'm not relating to this, but I'm just saying, like, why is it harder? It's harder because sometimes we might have, says we given the output, right? But then that doesn't mean that this input only for that one output, right? It could be 7 or 8. So that's the reason why it's harder to find the input when you are given the output. You see what I mean? Yeah, but that's a good answer there. So when you so you have this equation, and then they give you the output. So go ahead and substitute 17, replace y with 17, right? And then you use solving equation technique, and then you find x. Yep. So you guys got it right. Of course, I forgot to cover that. Yeah. So we're gonna skip 6 because I forgot to cover that. Oh, that's a good problem. Okay, so now, oh gosh, I gotta I gotta cover more. I thought I did it all, but I guess it's just easy. Oh, what did I just do? Well, let's just leave it like that. Okay, so here, so linear function. So what is a linear function? So before we get to that, let me tell you this. So we know what a function is, right? And so we know that there are multiple types of function as well. So for each degree, what I mean degree is just exponential number. So for each degree, there's a name for that type function. So for example, if I have something like this right here, y equals to mx plus b, the degree is 1, right? My input, which is x here, has the power of 1. So that's why it's called linear function. Why? Because the graph for this equation is just a straight line, okay? So that's why it's called linear function. So linear function can be written in slope-intercept form like this, or standard form like this, ax plus by equal to c. In this case, a, b, and c are just constants, just numbers, okay? Remember, you can evaluate a function by substituting values for x or f of x, okay? So, can you guys see, yes, can you guys see the problems like here at the end? I forgot to cover the answer, so I just don't want to show it. So for 1a, I have f of x equals to 8 minus 3/4 x. So is that linear function? It is, yes, it is. Very good. How about b? Is b a linear function? No, it's not. Yeah. No, it's not, because x doesn't have negative degree. Good job. Yeah. Very good. Okay. So let's do problem 2 together. Let's do problem 2. So like here, problem 2. Okay, yeah, so I have 2, A, B, and C. Why don't you guys try all those and then tell me the answer. So when you send me the answer, can you please send them to me privately? Thank you. All right, so the growth rate of a sample of Bermuda grass is given by the function f of x equal to 5.9x plus 3.25, where f of x is the total height in inches x days after initial measurement. So how tall the sample after 3 days? So to answer the question, you're gonna know which, you're gonna know what each letters represents, right? So you are given this functions. So what does x represent? Yeah, x represent number of days, right? And then your output f of x represent the total height. So you know what you're looking for, right? Yeah, that's good. Okay, so far I got one answer. Okay, one answer from Ian, another one from Richard, another one from Zach, Sean. Yes, you guys are great. Come on, I want to see more. I have 15 participants here. I have 15 people here. I know some are parents, so it's okay. All right, okay, so yes, the answer is 20.95 inches. Make sure, okay, by the way, when we do word problems, make sure you give me the unit, okay? So if I ask you how tall, you should put the unit inches there, okay? Just a reminder. All right, so the term 3.25 in the function represents the height of the grass when it's initially measured, okay? So the sample is how many times as tall after 3 days? You guys know what they asking you for? Yeah, that's good. Awesome, that's good. Yep, so approximately 6.44 times as tall. All you have to do is just divide this by 3.25, which is like a ratio thing. Okay, so if Bermuda grass is 50.45 inches tall, how many days has it been since it was last cut? So now what? Now you given the output, right? And then you calculate the input. Yeah, good. I got one. Let's see. Yeah, I got the answer from Richard so far. Richard. I'm so bad. Yeah, thank you. All right, anyone else? The output is 50.45. All you have to do is just calculate the input. And you given the function right here. The function is given right here. So how many days, huh? Yeah, Justin. Oh, wow. Justin. It's your first time hearing from you. Ishan, Ian. Very good. It is 8. 8 days. Yes, that's good. All right. So now we're moving on to something else. Okay. So now you know what a function is, you know how to evaluate function. So we're moving on to rate of change and slope, okay? So what is the rate of change? So rate of change is just a ratio that compares how much one quantity changes relative to the change in another quantity. So it's right here, I just read it off, I know. And then, so basically these two things are the same. So it's the same thing. It's the slope, right? So then to find the slope is delta y. When I say delta, it means change in y. Sorry, I shouldn't say that. I shouldn't say delta. Well, let's just call it change in y. Yeah, so which pretty much is rise over run. Yeah, so y over x, and then in your slope intercept form right here, you guys see it here, right? M here represent the slope, okay? So that slope, which is rate of change. Okay, so in this example, the rate of change is constant in the table. Find that rate of change and explain what it means for the situation. So you are given the formula right here, right? You have y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So 2 and 1, just the y's that you pick, up to you. So in this case, I have time, which is in days unit. So all these numbers, my x, which is my input, these number over here are my output, right? So how do I, yeah, very good. Yeah, that's good. So all I have is I take the change in y, right? So I can pick the first two numbers, okay? And then divide it by the difference between. Oh, okay. All right, yeah, I'm glad that you joined us. Thank you for joining us. I hope it helped and hope to see you in the actual class.
Thank you.
Bye, my pleasure.
Bye.
Okay, so then, yeah, so in this case, you take the difference of y and then you divide by the difference of x, right? So let's go ahead and calculate it. Yeah, that's good. Slope is 25. Good job. So then, same thing for problem 2 here, right? We got distance here. Yeah, that's good. And then we got hours here. Everyone, that's good. So $25 per day. So what does that, yeah, so that's what the slope means. Change per unit. Okay, that's good. Let's see. We done at, hold on, I just want to make sure that I don't go over. Okay, so we have until 7:30. Okay, we have until 7:30. Okay, so, okay, sorry, I have the answer here. But yeah, so same thing for slope, right? It looks like everyone knows. So to find slope, all you have to do is just find the difference of y and then divide by the difference in x, right? Output divided by input. And then rate of change, right, same here. You give it a 2 points. Oh, okay, you guys know x and y coordinates, right? Anyone here knows how to read the graph? Yeah, okay, cool. So yeah, perfect. So whenever you given a point, make sure you know that point always comes in two values, the input and the output, aka x and y values, okay? So the x goes with x-axis and the y goes with the y-axis. So yeah, okay, you know that, which is good. All right, so now we are moving on to writing linear equations. So when it comes to writing linear equations, I have tons of examples, which they're all good. But the three things you need to know is that you need to should know how to calculate the slope, know the point, and then the point slope form has to be memorized, okay? Because that will come in handy. You need that. Okay, so you have the two different forms. You have the slope intercept form, which is y equal to mx plus b, which is, you know, everyone knows about this, right? And then we have point slope form. So y minus y1 equal to m times x minus x1. So when we use this when you're given a slope and a point, right? And then we can we use slope intercept form when we know the slope and y-intercept, okay? Yes? No? Yes? Okay, cool, good. Let me erase this and cover that. Oh my gosh. Okay, sorry. Spoiler. Okay, this is not cool. Okay, so yeah. So for the first example, write equation in slope-intercept form, which is this one, y equal to mx plus b. Identify the slope and the y-intercept and the graph the line. Hi.
Hi.
Yeah, what's up? Hello? I just heard someone talking. No? Okay. Okay, cool. Yeah, so write the equation in slope-intercept form, right? So you already, yeah. So you already given the equation, right? So you can just change and then rewrite it. Wait, who's that?
Sorry, that's my brother.
It's okay. Oh, okay, cool. All right, so then you just have to convert this to your slope-intercept form, and then from here you know what slope and y-intercept is. Okay, so with that in mind, let's try problem 2 and 3. So for problem 2, you given the slope and then you given a point. So what did I say earlier? Which one do we use here? Given a slope and a point. So we use what? Which one? Go ahead and try 2 and 3, please. Yeah, point slope, yep. Very good. So for problem 2, I have y equal to 3x minus 2. Good job, Kelly. And then for problem 3, so when I have given 2 points, right? So hey guys, what can I find when I'm given the 2 points? The slope, right? So whenever that happens, when I'm given the 2 points, I can, yeah, exactly. You can find the slope and then know that I can find a slope, know that I'm given a 2 points. So that means that those 2 points lie on the graph, right? That means that I can pick any of them. I can pick any of them to be in my, to do with the slope-intercept here or the point slope here. Okay, so you can pick any of these and then write your equation right there. Yeah, that's it. Good job. Okay, so now we are moving to, let's see, well, okay, so 6:50. How am I doing so far? Good? Am I going too fast? Too slow? Good, okay. So let's see, operations of functions. Oh, these are easy. I'm gonna find something else for you to work on. So let me go over the lesson, and then we'll do, and then I'll give you some practice problems, like cooler ones. So you given f of x, which is here, it's already given, and then you given another function g of x, and then the third function h of x, and then the fourth function k of x here. So when they ask you to plug in, so for problem 1, I'm asking you to do f of x plus g of x, right? So that means that you, hey, has anyone here done operations with like numbers and variable? Something like this, yes? Okay, cool. Okay, good, good, good. I just don't want to leave anyone behind. Okay, that's good. Function composition, yeah. That's what I'm talking about. Okay, yeah, so that's great. I can just move on. I mean, I can just go faster. Okay, so when you add, it's easy, right? Go ahead and remove the parentheses. When you need to pay attention, when we do multiplication, something like problem 3. So when I do this, make sure you do FOIL, okay? So you pick 1 and you multiply, and then you do the same thing for 1. That's good. Okay, yeah, okay, we can move on. Here. So now we're moving on to composition of functions, right? So a function of a function. So I give you two functions here, f of x and g of x, right? So I can ask you to evaluate it. I can ask you to do like operations between them, or I can ask you to do composition. So something like g of f of 4, right? So that means that you do like a peeling onions layers, right? You start with the most inner and then you keep peeling. So let's try problem 1, 2, 3, and 4. So when I write something g f of 4, I can rewrite it as what? I can rewrite it as g of f of 4, right? So go ahead and try 1, 2, 3, and 4, please. Yeah, that's good. So for 1, the answer is 81. Wait, what? G of f of 4. So f of 4 is 4 squared minus 2 times 4, which is 16 minus 8, which is 8. And then f of 8, which is 3 minus 8, which is minus 5. Wait, it's not 81, it's minus 5. And then f of g of 4. So you rewrite it as f of g of 4. Sorry, this is not like a good solution. Oh yeah. Don't use these functions. Use here. Yeah. Yeah. That's okay. Yeah, do these here. F of x equal to x squared minus 2x, not the lesson. Yeah. Sorry. It's okay. Yeah, so 2 is 4, correct. So then you do f of g of 4, right? So the answer is 3. So g of 4, which is here, 3 minus 4, which is negative 1. And then f of negative 1. So negative 1 squared, which is 1, right? Minus 2 times minus 1, which is plus 2. And so 1 plus 2, which is 3. Okay? How about here? F of negative 1. So here, negative 1 squared minus, which is the same thing as here, right? Minus 1 squared, which is 1 minus. And so we have minus 2 times minus 1 becomes plus 2. And so f of negative 1, which is 3, then we down to f of 3, which is 3 squared, which is 9. 9 minus 2 times 3 is 6. So the answer is 3. So g of 100. So 1 minus 1, 3 minus 100, which is minus 97. Yeah, so the answer is 100. Good job, everyone. Very good. Yeah, so given a number, plug it into the function. Using this, yeah, so same thing, right? Using this and that to find this, f of g of x. So again, if you're not given a number, given a number, yeah, that's correct. So it doesn't have to be a number all the time. It can be a variable. In this case, x, right? So the answer is this. So I can move on. It looks like everyone knows how to do this. So now we are moving on to inverse function. Okay. And here. How about this? Yeah. Okay, so inverse function. The inverse of any function is the function that will do the opposite of f. So the function that will undo the effects of f, right? So does anyone know what the graph of the two inverse function look like? Anyone know? What's the name of it? No, not parabola. I mean, yeah, parabola is the 1-to-1, yeah. It's called 1-to-1 function, right? Okay, so if, yeah, that's what I'm looking for. It flips 180 degrees. So if an input 4 receive an output of 13, then the input of 13 will receive an output of 4. So that's what I call inverse function. So the inverse of function is written as f. So guys, I don't call this f to the negative first. I call inverse function of f, okay? Inverse function of f, okay? That's how you write it, but you don't read it as is how it's written, okay? So if f of x equal to x plus 2, then the inverse function of f is x minus 2. And then I'll show you how to find the inverse function later. These are just simple, but what if you run into like more complicated function, right? So go ahead and try 1a and b, please. Find the inverse function of each relation. 1, -3, -2 and 3, 5 and 1, 6 and 4. Remember, keep in mind that these are points, okay? And so the x value is 1, 2, 5, and 6. The y values are -3, 3, 1, and 4. So what's the inverse function for that? Anyone? So to find the x and y value for what you see, all you have to do is just flip it, right? So I switch the x and the y, so that's it, okay? All right, so you guys know how to find the inverse function. So here, let me show you how to find the inverse function. So when you're given a function, right, to find the inverse function, all you have to do is, first step, you rewrite f of x as y. Yeah, thank you, Richard. Yeah, so you rewrite it as y. So you write y equal to 4x plus 3. And then the next step is you switch x and y, and then you solve for y. Does that make sense? Anyone? Does that make any sense? Yeah. So y equal to, can you do an example? Yes. Here. I can do it with here. So I'm gonna bring it up here. So here, I replace f of x with y, right? So I write y equal 4x plus 3. That's my step number 1, okay? So next step is, okay. So my next is, I'm going to switch x and y like that. And then I solve for y, okay? Step number 3. Again, this is not my lesson plan. In my lesson plan, I'll list everything. I could have used it, but whatever. And then last step is solve for y, okay? So how do I solve for y? It's 4y equals, right? 3, 4y. You can write this if you want. It's easier to see, okay? And so that's give you here. I'll just do it like that. Okay, so then 4y plus 3 equal to x, right? You are solving for y, so it's going to be 4y equals x minus 3, okay? And then your inverse function, which is y equals what? X minus 3 divided by 4. Then you're done. So this is the inverse function of this. Does that make sense? Zach, did I answer your question? Ian, does that make sense to you? So let me go over this one more time. So you are given the function written as f of x or f of anything, right? Whenever you see that, just go ahead and rewrite it as y. So we're not doing anything here. We're not changing anything here. We just rewrite it, okay? So y equal to 4x plus 3. Now, the next step is when we do something. We switch x and y. So if I see y, I switch it to x. When I see x, I switch it to y. Okay, and then I solve for y. Yes, I heard something. Question? No? Okay. Yeah, so does that make sense? 7:30. Okay. Like this. See? X minus 3 divided by 4. So this is the inverse function of this. Okay? All right. So now you want to know, are the following functions inverses? They're asking, are these inverse function of each other? So can anyone answer? Is that a yes or a no? And how do we know? So whenever you give the two function, you plug each function into the other. So we can use what is it called, composition here. We can use composition function. And so if the composition of the two functions are the same, then they are inverse of each other. So if they are both equal to x, then yes, they are. They are the inverses of one another. Okay? So that's so here comes another type of problem that you might run into when you're given the graph, and then they ask you to graph the inverse function. So again, all you have to do is just switch x and y, right? So so the blue one is your function, and then the black is the inverse, or the other way around. The black is the function, and the blue one is the inverse. And then same thing here, okay? All right, so now we are is everyone here still with me? Okay, cool. I still have to, okay, cool. All right, so when I have parent function and transformation. So yeah, so now we are talking about different types of function, right? So we have linear function, which is degree of 1. We have quadratic, which is degree of 2. We have absolute value, which is f of x equal to absolute value of x. And then we have cubic, which is f of x equal to x to the third power. Okay, so these are parent functions because we're talking about transformation. Has anyone learned about transformation yet? Things like shift up, shift right, reflection over y, reflection over x. Yes? Okay, cool. If so, I can move on fast. So yeah, horizontal translation. So horizontal, when I talk about horizontal, it means the left or right, right? And so it only works, I mean, it only go, translation, yep, expansion, yep. Things like shrink or compress, stretch, yeah, those words, yeah. You guys got it. So if I have here my parent function, which is f of x equals to absolute value of x, right? And so if I have x plus 2, by looking at this, I know that only the x is affected, then I know that this is horizontal translation, left or right. So how do I know when it's left or right? When my x is added, it's left, right? When my x is subtracted, it's right, okay? And then we're talking about reflection, something like this. So this is the reflection of the parent function x squared, okay? All right, so how about these? Okay, so given the name of parent function and describe the transformation represented, sketch using a table. See, don't worry about it. Okay, so here I have function g of x equal to x squared minus 4. What is the name of that function, guys? Yeah, very good. Thank you, Zach. Yeah, Rishabh, you're right. How about B? Very good. So yeah, because so let's take a look at my function over here. My x value is not affected by anything, right? And then in this case, everything here minus 4. So I know that this is go up or down 4 units. So now this is minus, so I know it's down by 4 units, right? So let's take a look at B. I know that my x value here is affected by 5 because it's being added to 5, right? So I know that this is horizontal shift and then minus 2 outside. So this is left or right? It's positive, so it must be left, right? And then down 2 units, so that's it. And this is what the graph looks like. Good. So now I give you the description. Go ahead and write the function, the new function for me, please. Is linear and vertical shift up 5 units. What is it? What does the transformation function look like? So that's good. So the equation f of x equal to x plus 5 because it's up 5. And then horizontal shift right. So right minus and then down 5. So that's it. That's good. So let me see. All right, so that's it. Unit 1 for everyone. How was it? How was it, everyone? We just finished one unit about function. So yeah, so usually what I do is I can show you quick what my lesson plan looks like. So like so if you in later later if you in where's my drive? So later on when you're in this class, I'll share with you my lesson plan, and so so it'll be something like this, like I write it, and then we learn, and then we do examples as we go. So that's how I do it. And then for problems, we do something from the book. So for example, like today's lesson, right? It's about equations and like functions. So I can go to functions, which is, no, it's not quadratic. Yeah, which is unit chapter 1 and 2. So like I can ask you something like this, operation, and then example, so variable, something like evaluate the expression. So things like this that you'll see in algebra 2. So I want to see what everyone thinks about today. Like I know tryouts, and again, we'll do more problems and more like a interaction. Like it's I hope it won't be just me talking. I want to like that's why I ask questions all the time, because I want you to be with me. I want you to like I want to make sure that everyone's with me, okay? Like that I'm not leaving anyone behind. Or if you have any question, feel free to ask me. You can either send me a text privately, or you can just like unmute yourself and speak up, okay? So how was it for everyone? Hello? How did it go today?
Good.
Good. Okay. Easy. Yeah. I picked like the most easy one just so I can go over and it's like for tryouts. Yeah. Thank you, Zach. Thanks for your kind words. Yeah, I hope to see you all in the actual class. Yeah, to be honest, you guys are really good. And so knowing that you guys are good and like everyone on the same page, so I know what to do next week. Does it start next week? I don't remember. But yeah, yeah. So now I know that everyone good, well prepared, ready to go. So the next class will be more like a true algebra 2 lesson. I'm not saying it's going to be harder. I'm just saying like more like a good algebra 2 lesson. Yeah. Any question again? Oh, how's online schooling for everyone? Are you guys taking algebra 2 at school right now? From you, yeah. Oh, some of you will. Okay. Oh, so you will take. Okay, we'll take algebra 2. Yeah, yeah, awesome. So yeah, I feel like if so, this course will help you a lot. Yeah. So okay, bye Ryan. I really hope to see you in the actual class. So just for your information, the class will start in September. Let me check the date. Yeah, so class will start in September. So actual class will start here. Let me send everyone. Okay, so class, so Algebra 2 will start from September 13 to December 13. And during that time, no class on November 22nd and 29th. Yeah, I know. Yeah. Thanks, Kelly. Yeah, I just wanted to pull up just like, yeah, just something. Yeah, so I'll see you guys hopefully on September 13, okay? Thank you everyone for joining me today. I hope everyone enjoyed it. It's math, so I try my best to make it interesting, but yeah. Okay, thank you. I'll see you on September 13, okay?
Thank you. Bye.
Bye.